double integral double integrals as the definite integrals of functions of two variables. Definite integrals of functions of two variables. Case 1. Case 1, when region R equal to function of x and y is rectangular. That is, both boundaries are parallel to x and y axis, like this. This is your y axis and this is your x axis. Okay, and boundaries, all boundaries are parallel to x and y axis, that is like this. And these two boundaries are parallel to x axis. This is parallel to x axis, y equal to c and y equal to d. This is your origin, and these two boundaries of this region are parallel to y axis, that is x equal to a and this is x equal to b. Now the region is, this is the region R. This shaded region we can find. This is the region. Naturally, then double integral f of xy dx dy on the region R will be equal to integral x equal to a to x equal to b phi of x dx multiplied by integral y equal to c to y equal to d function of psi of x dy. Here the variable can be when separated, and the function of xy will be separated in the variable x and y, and this is the formula. Now we will show an example, that is problem 1. Problem 1. The problem will be with the help of this type, that is belongs to case 1. Example 1 / problem 1. Evaluate integral 0 to pi by 2 0 to pi sine of x plus y dx dy. Now solution will be integral 0 to pi by 2, 0 to pi sine of x plus y dx dy equal to integral 0 to pi by 2, 0 to pi sine of x plus y. Here this integral we can the variable of dx either dy. Suppose this is dx, or you can it can be also the variable dy. Now I am just this is dx, then this integral will be, and after that this integral will be, and dy is the variable of this integral. Therefore 0 to pi by 2 minus cos of x plus y, because here variable is x, that is integration will be with respect to x. Zero to pi dy, or this will be 0 to pi by 2 minus cos of pi plus y minus cos y dy, and this will be 2 integral 0 to pi by 2 cos y dy, and now this will be 2 sin y 0 to pi by 2, that's equal to 2, and this is the answer. This example belongs to case 1. Here these two variables can be separated, and both the limit of integration here both the limit of integration in this upper, both the limit of integration both are constant, so no problem, this is very easy. But when case 2 will become, that is this type of case 2 will be case 2. Case 2, when region R has two linear boundaries parallel to y-axis. When region has two linear boundaries parallel to y-axis, like this, this is your x-axis and this is your y-axis. These two boundaries, therefore, parallel these two lines, parallel to y-axis, and this is your x equal to a and this is x equal to b, and two other two boundaries are any this type of curve, any like curve, and this is the equation have y equal to phi 1 x and this is y equal to phi 2 x. So this is the region R, this is the region R. Okay, this is the origin O. So this, on this region the double integral will be f of rule dx dy equal to integral f of xy dy, and this is dx and this is x equal to a to x equal to b, and this is y equal to phi 1 x to 5 to x. Carefully notice that this is very, very important to remember that. This is very, very important to remember that last limiting value of the integration will be constant, that is last integral. First integral will be this is the first integral. After the value of this integral, the last integral, this limit must be constant. So naturally this cannot be here. Before that this will be, because last integral will be constant. Now this type of problem we will show. Example number 2. Example number 2. Example 2, problem 2. Evaluate double integral of 4x square minus y square dx dy over the integral over the triangle formed by the straight lines y equal to 0, x equal to 1 and y equal to x. Now the solution will be integral double integral 4x square minus y square dx dy. And before we finding this value double integral, we will draw the picture. This is the picture. This is your x-axis, this is your y-axis, and this is your y equal to 0. That is, this is y equal to 0 x-axis, and x equal to 1. That is parallel to y-axis. This is x equal to 1, and y equal to x-axis. That is, this is y equal to x. This is your origin. Now the region is, this is the region R. So we will find the double integral on this region. And this is 1, 1. So therefore this double integral will be integral 0 to 1, integral 0 to y equal to x equal to 0 to x equal to 1. This is will be constant, and this is y equal to 0 to y equal to x, because to this formula. So therefore this is 4x square minus y square dy, and this, because last integral limit are constant, that is 0 to 1, and before finding this we will find that this limit will be variable. This is the very short process, and this will be integral 0 to 1 y under root of 4x square minus y square by 2 plus 4x square by 2 sin inverse of y by 2x 0 to x dx, and this is the value, and this will be integral 0 to 1 x root 3x by 2 plus 2x square pi by 6 dx, and this is after simplification this will be root 3 by 2 plus pi by 3 common 1/3, and this is the required answer. So in this way this solution will be in case 2, and next case 3 will be shown later. So try yourself. So please don't forget like and subscribe and click on the bell icon if you not subscribed before for notification.